So this is our last video, and this video is going to talk about limits at infinity. And remember, this means we are talking about limits of the form limit, let me undo this, sorry. Limit x goes to plus infinity, f of x, or limit as x goes to minus infinity, f of x. So that's what I mean with the at infinity. So at infinity means that we've got x approaching plus infinity or x approaching minus infinity. Okay, and now we're just going to run down some examples. The first example here is going to be, let's do example 1. It's going to be just the limit as x approaches plus infinity of e to the x. So in order to figure out this limit, we need to know the limit of, we need to have an idea of the graph of y equals e to the x. It looks something like this, y equals e to the x. And we could graph 3 points on here. So for instance, that could be 0, 1. That could be 1, e. And this one could be negative 1, 1 over e. Please make sure that you have your graphs. You're very familiar with your common graphs, y equals e to the x, y equals a to the x, power graphs, your tangent, your cotangent, not your cotangent so much, but your trig graph, sine, cosine, tangent, you should know those. Also arctangent, we'll do an example with arctangent. So if we are going with, this is our graph for, y equals e to the x. We're actually going to use this to do several examples. So the limit is x goes to plus infinity e to the x is going to be equal to plus infinity. So as x is getting bigger and bigger, as x is getting bigger and bigger, the y values are getting larger and larger. Okay, our second example, what is the limit as x goes to negative infinity of e to the x? So now here is x is approaching negative infinity, e to the x is approaching 0. Okay. Now another way to see that is we have a horizontal asymptote. So remember or recall the fact from class that if f of x has a horizontal asymptote, at y equals L, then the limit as x goes to plus infinity f of x equals L, or the limit as x goes to minus infinity f of x is equal to L. And so for us, in this case right here, with this example here, L equals 0. Okay. Now let's look at the limit as x approaches plus infinity of e to the negative x. And here's how we think about this. So the way to think about this is to say that as x approaches plus infinity, negative x is approaching minus infinity. And so we're going to look at our graph, and as negative x is approaching minus infinity, e to the negative x is going to be approaching 0. So we're going this way. So what's happening to e to the negative x? It's going to be going to 0. So this is equal to 0. And let's do one more, which is the limit as x approaches negative infinity, e to the negative x. And now here we're going to use similar reasoning, and we're going to say as x approaches negative infinity, negative x dc, let me try to highlight this. Negative x is going to be going to plus infinity. Okay. So e to the negative x is going to be going to plus infinity because the exponent here is getting larger and larger and larger, and we can look here, look to our graph, as the exponent gets larger and larger and larger, the values go to plus infinity, so we get plus infinity. Okay. Now, what about let's see, what about the limit as t goes to negative infinity of e to the t to the fourth minus 5t squared plus 1. Okay. So we have, again, here's our sketch for e to the x. So this is y equals e to the x, and here's x. Now notice that the fact that we have t doesn't change anything. This is the same as if we were calculating the limit as x goes to negative infinity, e to the x to the fourth minus 5x squared plus 1. It's just a variable, and it's just what we're naming the variable with. If it's t, if it's x, it doesn't really matter. Okay. Now, let's see here. So here's how we think about this. So we think as t approaches negative infinity, what happens to t to the fourth minus 5t squared plus 1? Well, t to the fourth minus 5t squared plus 1 is going to approach plus infinity. And remember, we looked at why this is true in class on Wednesday. So check last Wednesday's notes.
It's 10 o'clock.
For this portion right here. And for us, what we're going to use now is we're going to say, so e to the t to the fourth minus 5t squared plus 1 is going to approach plus infinity because this numerator, the numerator is getting really large, right? And so e, when your numerator is, or your exponent, not numerator, your exponent, when your exponent is getting really large, the larger your exponent gets, the larger e to the exponent gets. And so our limit is going to be plus infinity. What about the limit as t approaches plus infinity? E to the t to the fourth minus 5t squared plus 1. We're also going to get plus infinity because as t goes to plus infinity, t to the fourth minus 5t squared plus 1 is also going to go to plus infinity. So e to the t to the fourth minus 5t squared plus 1 is going to approach plus infinity. Okay? Let's do some more examples here. What about the limit? Oh, no. Oh, well, this is kind of similar. What about this? So we'll call this, we're still dealing with our graph of y equals e to the x. Okay? So y equals e to the x. So if we have the limit as z approaches 0 from the right, e to the 1 over z. So notice that this is not a limit at infinity because z is approaching 0 from the right. This is, however, an infinite limit. The reason why is because, let's look at this, as z approaches 0 to the right, what happens to 1 over z? So we're looking here at our exponent. What happens to 1 over z? Well, now we need to remember, what does 1 over x look like? 1 over x starts looking like this. I don't like the way that looks. Let me... So this is our graph of y equals 1 over x. Have this memorized. Right? Okay, so as z approaches 0 from the right, and I'm going to use a different color here. So this is the same thing as x is approaching 0 from the right. 1 over z is approaching plus infinity. Okay? So now we take that and we say, so e to the 1 over z is approaching plus infinity, because these terms are going to plus infinity. So e to these terms are going to plus infinity, because as exponent tends to plus infinity, e to exponent tends to plus infinity, okay? And as the exponent tends to minus infinity, e to the exponent tends to 0. Okay, so that's the major idea that we're using again and again and again. And let's do another example here. So we're going to do, what is the limit as x approaches plus infinity? E to the 10x minus 4e to the 6x plus 3e to the x plus 2e to the negative 2x minus 9e to the negative 15x. Okay, so wow, this is a lot. This is big. And here's what we're going to do. So the first thing we're going to do is we're going to, if we just try to look at each term, so let me do this actually I'll do it in green. So attempt 1. So this is going to be our first attempt. Will be to say that e to the 10x is going to plus infinity, right? Since as x goes to plus infinity, e to the 6x is going to go to plus infinity. So 4 times e to the 6x is going to go to plus infinity. E to the x goes to plus infinity. So 3e to the x goes to plus infinity. E to the negative 2x goes to 0. So 2e to the negative 2x goes to 0. And e to the negative 15x goes to 0. So 9 goes to 0. So then we would have plus infinity minus infinity minus infinity plus 0 minus 0, indeterminate form. Right? So we need attempt number 2. And attempt number 2 is going to be to factor out dominant terms. Now we did this, I didn't call it dominant term before when we did it on Wednesday, but it's essentially what it is. So you want to factor out the term that's having the biggest impact, the biggest term. Okay, so let's go ahead and do that. So I want to copy, paste. Okay, here we go. All right. So here's what I'm going to do. My dominant term is going to be e to the 10x. Okay, so now I'll have 1 minus 4 e to the negative 4x, right, plus 3 e to the negative 11x, plus 2 e to the negative 12x, minus 9 e to the negative 25x. Okay, so this is equal to the limit as x goes to plus infinity of all this stuff. Now I can say that this is going to go to 1, right? So this is as x goes to plus infinity. 1 goes to 1. This is going to go to 0, right? Now why? Let's look at that. So as x goes to plus infinity, negative 4x is going to go to negative infinity. So e to the negative 4x is going to go to 0. So I did all those 3 steps in one. Okay. Now, this is going to go to 0. Check to make sure you understand why. This term is going to go to 0, and this term is going to go to 0. Okay. So, this term is going to plus infinity. So now what we have is essentially something that's going to plus infinity times something that is going to 1. So let me put this in. So we've got, let's go with the little color scheme here. So this back part right here, all of this is going to 0. And this part right here, all of that is going to plus infinity. I clearly made a mistake because plus infinity times 0 is an indeterminate. So checking, I see that, wait, this is not going to 0. This is going to 1. Because remember, we've got that 1. So this is going to 1. So now I'm comfortable with saying that my limit, as x goes to plus infinity of that thing, e to the 10x minus 4 e to the 6x plus 3 e to the x plus 2 e to the negative 2x minus 9 e to the negative 15x is equal to plus infinity. Okay. Let's do another one. So here we're going to have, let's do the limit, and x is going to minus infinity of 6. Can you call this out to me?
6 e to the 4x
E to the 4x
minus e to the negative 2x
minus e, let me undo it, minus e to the negative 2x,
all over
okay, divided by
8 e to the 4x minus e to the 2x plus 3 to the negative x.
3e to the negative x?
Yeah, 3 e to the negative x.
Okay.
And here you have the limit is going to plus and minus infinity.
Right. First I'll do the minus infinity, then I'll do the plus.
Okay.
Thank you all. Okay. So how are we going to do this? Well, let's see here. So we'll do a couple of attempts. So the first attempt is going to be like so. That'll be attempt number 1. We're going to say this goes to 0, this goes to plus infinity, this goes to plus infinity, this goes to plus infinity, this goes to 0. this is going to give us infinity over infinity minus infinity. Notice this is not equal to infinity over 0. Not equal to infinity over 0. The fact that we have this in the denominator means we have indeterminate. Indeterminate form. Okay, so let's go to attempt number 2. Attempt number 2. For attempt number 2, what we're going to do is we're going to factor out our dominant term. Our dominant term is going to be e to the 4x. So in the numerator, we'll get 6 minus e to the negative 6x. And in the denominator, we will have e to the 4x times 8 minus e to the negative 2x plus 3e to the negative 5x. Okay. Now the e to the 4x is going to cancel out, so we just end up with 6 minus e to the negative 6x divided by 8 minus e to the negative 2x plus 3e to the negative 5x. And we can now say that this is going to 0, this is going to 6, this is going to 8, this is going to 0, this is going to 0. So the limit as, wait. I've been doing this problem. Let me go back and change this to, but now we want x to go to minus infinity. Okay. So here, let's look at, we'll again do attempt number 1. Notice that I'm not even trying to draw these. I'm not trying to sketch them. I'm just going straight to looking at dominant terms. And I need attempt number 1. So attempt number 1 is going to be to say, command paste. So now we're saying as x goes to negative infinity, this is going to go to 0, right? So as x goes to negative infinity, 4x goes to negative infinity. So e to the 4x is going to go to 0. So 6 times e to the 4x is going to go to 0. Okay, so all of this went into explaining this arrow here. Okay. All right, so down here, this is going to go to 0. E to the negative 2x, that's going to go to plus infinity. So let's look at that. As x goes to negative infinity, 2x goes to negative infinity, negative 2x goes to plus infinity. E to the negative 2x goes to plus infinity. Okay, so that's how we're doing that. Now e to the 2x goes to, what does e to the 2x go to? E to the 2x is going to go to 0. And 3e to the negative x is going to go to, let's see here, x goes to negative infinity, negative x goes to plus infinity. So e to the negative x is going to go to plus infinity. So 3 times e to the negative x is going to go to plus infinity. So this is going to go to plus infinity. So we now have an indeterminate form. So we get infinity over infinity, which is indeterminate. So what this tells us is that we need to factor attempt number 2. we're going to factor. So we've got this is equal to, this fraction is equal to, now what do we factor? Notice that essentially our leading term now is going to be e to the negative 2x. That's going to be the leading term, the dominating term. So this term right here is going to be the dominating term in the numerator because it's going to plus infinity, whereas the other term is going to 0. So let's factor that out, and we'll get negative 1 plus 6e to the 6x. Okay? And then, in the denominator, what is the leading term? In the denominator, the leading term is going to be e to the negative x. You could put 3e to the negative x, or you could just put e to the negative x. I'm just going to put e to the negative x just to, who cares, just to be done with it. So I'll have 3, okay, and then I'll have minus e to the 3x, and then I will have plus 8 e to the 5x. Okay? And so now, looking at it, I'm going to erase some of this that we did over here so I can have some more space. So now, the negative 1 is going to go to 1. This is going to go to 0 as x goes to negative infinity. This is going to go to 3. This is going to go to 0. And this is going to go to 0. Okay. So now what's going to happen with e to the negative 2x versus e to the negative x? So e to the negative 2x divided by e to the negative x is going to be equal to, what is that equal to? Should be e to the negative 2x minus negative x. So we should get e to the negative x. Okay. So we can rewrite this as e to the negative x times, we'll have this negative 1 plus 6 e to the 6x over 3 minus e to the 3x plus 8 e to the 5x. And now notice that all of this is going to negative 1/3 as x goes to negative infinity. This is going to what? It's going to go to plus infinity as x goes to negative infinity. So my limit, x goes to negative infinity, of this is going to equal plus infinity. Okay? And so this is going to be my answer overall. So it's really important to get something, to get a product of two things. And it can't be an indeterminate form. So we said this is going to negative 1/3. The first product is going, or the first factor is going to plus infinity. So now, as I multiply these two things together, wait, I need to have minus infinity. Good catch, good catch. This needs to be minus infinity, okay? Because this, the e to the negative x term, is getting really large. It's becoming a really large positive number. And this quotient is becoming very, very close to negative 1/3. Okay, so when I multiply these two things together, I'm going to get a really large negative number. So my limit is negative. Good, good, that's good. That was a good example. I liked it. Let's do another example. This example here is the limit as x goes to negative infinity, e to the, I want to do this neatly. Let's start over. Sorry about that. I'm just going to try to do this very neatly. Okay, so we want the limit as x goes to negative infinity of e to the 6t minus 4e to the negative 6t divided by 2e to the 3t minus 5e to the negative 9t plus e to the negative 3t. Okay, so this is what we're trying to compute. And let's do our first attempt. So attempt number 1. So looking at this, we've got, now remember, as x approaches negative infinity, so we've got x and we've got t. Let me change this to a t. Okay. And so then this is going to be a t. So as t goes to negative infinity, 6t goes to negative infinity. So e to the 6t is going to go to 0. So this is going to go to 0. This is going to go to plus infinity. This is going to go to 0. This is going to go to plus infinity. This is going to go to plus infinity. So make sure you understand why. For all 5 of these, the process is very similar to the process that we did over here to figure out the first one. So what I see is that I need to factor, because I'm going to have, from attempt number 1, I will have indeterminate form, because I'll have negative infinity over negative infinity plus infinity. And so in the denominator will have an indeterminate form. Okay, so to factor, I need to figure out what is my dominant term. In the numerator, because this term right here is going to plus infinity, I'm going to use e to the negative 6t as my dominant term, and I'm going to factor it out. So I'm left with negative 4 and then plus e to the 12t. Okay? And in my denominator, my dominant term, how do I determine my dominant term? Because in the denominator, we've got 2 terms that are going to plus infinity. Well, the issue is which one goes to plus infinity faster. Okay? And because the 9 is bigger than the 3, this e to the negative 9t, this one is going to win out. So I'm actually going to use this one. And we'll learn about this more. And so in fact, let me write this down. This is ultimately a question of which grows faster as x goes to negative infinity. E to the negative 9x or e to the negative 3x. And so the answer would be, as an answer, right now you could check it out. Answer for now check out Desmos and look at the graphs and see which graph grows and see which graph grows faster. In a few weeks, we'll answer this question using derivatives. So soon, we'll use derivatives. Right? Yay, that's what we came for. Okay, so in the denominator here, I'm going to pull out my e to the negative 9t. What will I have? I will have negative 5. Okay? And then instead of the plus e to the negative 3t, I'll have plus e to the, I think, 6t. Let's see. Yeah, that works out. And then lastly, I'll have plus 2 e to the 12t. Okay. So now I can rewrite this because I've got this e to the negative 6t and the divided by e to the negative 9t. I can rewrite that as e to the negative 6t minus negative 9t. Okay, and I've got times that stuff over there. So I'm going to get
10:30
e to the 3t. Okay. Now over here, what do I have? I have negative 4 plus e to the 12t. And then down here I've got negative 5 plus e to the 6t plus 2 e to the 12t. So I've got, let's see here, e to the 3t times negative 4 plus e to the 12t divided by negative 5 plus e to the 6t plus 2 e to the 12t. Okay? So now let's look and analyze as t is approaching negative infinity. This is approaching 0. This is approaching 0. This is approaching negative 4 because it's a constant function. This is approaching negative 5. This is approaching 0. This is approaching 0. So all of this is approaching 4 over 5. All of this is approaching 0. So all of this is approaching 0 times 4 over 5 is equal to 0. Okay, so I'm going to say back here up at the top, so up at the tippy top here, my limit. What is my limit? That was the original question. And the answer is this limit is equal to 0. Okay. Now, these are taking a long time for me to do because I'm explaining each and every little step and I'm doing 2 attempts. It is very important for you to do those practice problems. And if you're having difficulty doing the practice problems, right, if you're needing to look and see how to do each and every single step, come to office hours. Come and get help, okay? Because you want to make sure that you can do these limits, quickly, and you're not, you don't want to stumble around with them. And the way to be able to do them quickly is to do a lot of practice problems, okay? So let's see here. So let's go to a different type of example. And so I'm going to actually call this example 2 because we've got a totally different type of example here. Let's look at the limit as x goes to plus infinity of the natural log of x. This is another graph, where you need to have it memorized. So looks like this. Y equals natural log of x. Memorize this. We can put in 3 points. So the 3 points we could put in would be 1 comma 0. This should be e comma 1. So let me just try to draw this better. So how do you get the natural log graph? And I've done this in class, but I'm just going to repeat it pretty quickly here. You start off with your e, y equals e. Okay. And remember, for e, we had these 3 points here. So this one was -1 comma 1 over e. This one was 0 comma 1. And this top one here was 1 comma e. Okay. So you take this and you reflect it over the line y equals x. And that's how you get the inverse function, which is the natural log. So let's see here. So you're going to get something that's like something like this. Now, this point is going to be e comma 1. This point is going to be 1 comma 0. And this point is going to be 1 over e comma -1. Okay? And this is your natural log. This is your y equals natural log of x. That's what I'm saying. Memorize this. Okay, be able to create it. Now, from the graph here, we can tell that the limit as x goes to plus infinity is going to equal plus infinity. Why? Because when we look at e to the x, it's going to plus infinity. Ooh, sorry. And as x is going to plus infinity, natural log of x is going to plus infinity too. What about the limit as x approaches 0 from the right of natural log of x? As x approaches 0 from the right, so that means that x is getting really, really small. What's happening to the y values? The y values are approaching negative infinity. So notice that this is an infinite limit. This is not a limit at infinity. Not a limit at infinity. This is an infinite limit, right? And they talked about that during the presentation. Now let's bump it up a notch and let's say, what is the limit as x approaches plus infinity of the natural log of 7x cubed minus x squared plus 1? So how do we think about this? Well, as x approaches plus infinity, 7x cubed minus x squared plus 1 approaches plus infinity. Because recall from class, that fact that said the limit as x goes to plus infinity of 7x cubed minus x squared plus 1 is going to be the same thing as the limit as x goes to plus infinity of 7x cubed, right? So you just have to look at the dominant term. And we know that the limit as x goes to plus infinity of 7x cubed is going to be plus infinity. So since we know that 7x cubed minus x squared plus 1 goes to plus infinity, as x goes to plus infinity, the natural log of 7x cubed minus x squared plus 1 is going to go to plus infinity because it's going to go to plus infinity. It's not equal to plus infinity. It's going to go to plus infinity because these numbers are getting big, getting really big. And as the argument of log gets big, the value of log gets big. Okay, that's what it means to say that the limit of natural log of x is equal to plus infinity. Let's do another one. What about the limit as t goes to negative infinity of the natural log of 1 over t squared minus 5t. Oh, wow. Okay. So here, so again, I'm just to help myself out here, I'm going to draw my picture of natural log. Okay. So as t goes to negative infinity, t squared minus 5t is going to go to plus infinity, right? Because think about it, think about it in terms of the fact that we had from class. Limit as t goes to negative infinity of t squared minus 5t is the same as the limit as t goes to negative infinity of t squared, right? And the limit of t squared as t goes to negative infinity, this limit is equal to plus infinity, right? So t squared is just going to be a parabola, right? And as t is getting really negative, t squared is just getting really, really big, positive, okay? So as t goes, so we're back over here. As t goes to negative infinity, t squared minus 5t is going to plus infinity. So 1 over, so the reciprocal of t squared minus 5t, it's got to be going to what? It's got to be going to 0. And it's going to 0, but it's going to 0 from the right. Okay, so these are all positive numbers. So these are all positive numbers. Right? And the denominator is getting really, really big. So this is big and positive. So 1 over big and positive, 1 over big and positive is going to be small and positive, right? So that's the idea. You can even put in here really big and positive is going to be really small, right? So for instance, 1 over 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, right? This is a big positive number. It's going to be 0.123. This is 10 to the 6. We have 0.123456781, right? Really big and positive, and this is really small and positive. Okay, makes sense. All right. So back to our problem that we're looking at here. So let's actually kind of just start again. So let's see here. So we've got so our goal is to find the limit as t goes to negative infinity of the natural log of 1 over t squared minus 5t. Okay. So we said, just to keep in mind, we want to have a picture here of natural log. Okay. Now, as t goes to negative infinity, t squared minus 5t is going to go to plus infinity. So that means the reciprocal, which is 1 over t squared minus 5t, is going to go to 0. But it's always going to be a positive number. Okay? So the natural log of 1 over t squared minus 5t is going to be approaching negative infinity. Okay. Now, the reason why we have to emphasize that this is a positive number is because if this were a negative number, then we couldn't take the natural log of it. It's not in our domain. Okay. So lastly, let's go to our third example here. This is our third function that we're looking at. And it is arctangent. So arctangent. You want to make sure you know arctangent because it's got important properties. Oh, undo that. This is how I like to draw arctangent. Arctangent has asymptotes. At pi over 2 and negative pi over 2. So this is pi over 2. This is negative pi over 2. Okay. So for our example here, we're looking at the limit as x goes to plus infinity of arctangent of x. This is y equals arctangent of x. So the limit as x goes to plus infinity is going to be pi over 2. The limit as x goes to minus infinity of arctangent of x is equal to minus pi over 2. And let's see, what is the limit as x goes to plus infinity of arctangent of
It's 1045.
X cubed minus 5x plus 6. Okay, so we think about this as follows. As x goes to plus infinity, x cubed minus 5x plus 6 goes to plus infinity. Okay, so our tangent of x cubed minus 5x plus 6 goes to pi over 2. Okay, because if these values are getting big, and then we look up here, and as your input is getting really big, arctangent is getting closer and closer to pi over 2. So this limit is equal to pi over 2. Okay, and then the last thing we have is what is the limit as x approaches 0 from the left of arctangent of 1 over x. And so we're going to say as x approaches 0 from the left, one over x approaches plus infinity. Wait, no, it's going to be minus infinity. Okay, because here's the idea. I can even do my sign analysis. I can have here's 1, and here's x, and here's 0. 0, positive, negative. 1 is just always positive, right? So 1 over x is going to be positive, 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 positive over here, negative, negative, negative over here. So if I'm approaching 0 from the left, my values are negative, right? So I'm going to have negative infinity. So now 1 over x is approaching negative infinity, and arctangent of 1 over x is going to be approaching negative pi over 2. So this limit is equal to negative pi over 2. Okay, so I know that so this is the end of my video here. I know that these videos have been very long. I wanted to include them because I wanted you to have some solid examples of computing limits even if you don't have Desmos. In other words, these are things that you're going to be expected to be able to do on the exam. Okay, so please make sure that you are understanding how to get these limits and that you are going back and reviewing your graphs of common functions. If you don't remember arctangent, look it up. If you don't remember natural log, look it up. If you don't remember e to the x, look it up, okay? Things like that. All right. Thank you. Bye.